Hello, everyone. In this video lecture, I would like to talk about profit maximization, which will cover materials from our lecture series that I already uploaded in the Blackboard. So in the previous video that is already uploaded in your Moodle, we talked about various aspects of production and cost. I would like to complete the discussion by combining these two ideas and talk about profit maximization. I will therefore cover the last part of the the handout that is being provided to you that discusses production and cost. I would like to start with by sharing my screen with all of you. And what I want to do is before we start looking at the handout and basically follow the discussion in that handout, I would like to speak a little bit about the kind of market structure that we are going to be looking at to highlight the issue of profit maximization. So in the handout, you have read about perfect competition, which is a type of market structure that is fairly unrealistic. I would say that it's a hypothetical market structure. But in economics, we use that hypothetical market structure to give students a basic understanding about what profit maximization is and how profit maximization can be ensured. So I would like to start today by talking about the idea of perfect competition. So perfect competition is a kind of market that is based on several unrealistic assumptions. One of them is that there are a large number of buyers, which can be true in many cases. And there are large number of sellers as well, which again can be true in some cases, but not always. The goods that are being produced and sold are homogeneous, meaning that they are identical, which means that regardless of which seller is producing and selling that product in the market, these goods are identical. So these three assumptions together leads to a situation where buyers and sellers are basically price takers, which means that based on the sheer size of the buyers and the sheer size of the sellers, we assume in this hypothetical market that neither the buyer nor the seller can control the market price. So they will take the market price as given. Now, these assumptions create sort of like a unique situation for our producers in the market. One interesting outcome of these assumptions of perfect competition is that you can have a downward sloping demand curve and an upward sloping supply curve for the market. And the interaction between the demand and supply curve can determine the market equilibrium price. But when it comes to an individual firm, the demand curve our firm faces at that price level is going to be a horizontal line. So as a result of the assumptions that we have imposed, the market demand curve is going to be downward sloping and the individual demand curve is going to be a horizontal line. So what does it mean? It means that since our sellers are price takers, meaning that they cannot control they cannot control the market price, they will take the market price as given. So price takers means take the price as given. That significantly simplifies the decision made by our producers in perfect competition, because they do not have to worry about what kind of price they are going to charge in the market. Again, you can see that this is highly unrealistic. Part of it is because we live in markets, or we interact in markets where we know and see firms having substantial amount of market power where they can control the market price. Later on, you will see that as a result of those changes, as a result of that gaining market power, the demand curves for an individual firm will change. But for the time being, for the sake of the discussion that we are about to start, which is profit maximization, our firms are price takers. Now, this is very, very important because this tells us that our firms cannot really control the market price. They take the market price as given, and at that market price, a firm is allowed to produce and sell any quantity of output because the demand the firm faces at that market equilibrium price is indefinite. That's why you get a horizontal demand curve. And the reason why you get this indefinite demand is because goods that are being produced are homogeneous, which means that our buyers cannot distinguish between firm A, firm B, firm C, or any other firm in the market. Now, having a horizontal demand curve has significant implication for our firm's profit conditions. But before we do that, let us remind ourselves about certain concepts. First of all, I am going to talk a little bit about the marginal revenue curve and average revenue curve. So we know that total revenue is price times Q, and our marginal revenue is when you differentiate total revenue with respect to Q. So marginal revenue refers to the extra revenue you get when you sell an extra unit of output. If you apply simple rules of differentiation, you find that your marginal revenue is actually equal to price. Now, what does it mean? It means that anytime a firm is trying to sell something, the marginal revenue it will get will always be equal to the price it charges for that particular product. Now, this is important because if our price is fixed, P star, according to the market equilibrium P star, you can see that the marginal revenue will always be equal to the market equilibrium price. This is a highly unusual situation because in perfect competition, prices don't change, hence marginal revenue don't change. So therefore, we can write the demand curve as just like a marginal revenue curve, which basically says that for every extra unit of output the firm is selling, it gets the same price back, which is nothing but the marginal revenue it earns. So that's one important result. The other one that we are going to look at is total revenue. Total revenue is average revenue. So average revenue is total revenue divided by Q. And if you expand the definition of total revenue, which is P times Q, and you divide that by Q, you also find that your average revenue can also be equal to the price. Now, again, if the price is constant, meaning that the firm is facing a horizontal demand curve, the average revenue curve can also be identical to the marginal revenue curve. So sometimes in perfect competition, therefore, we say that our demand curve for an individual firm, the marginal revenue curve, and the average revenue curve are all identical. So with that notation, I am going to now go back to the discussion about profit. So in your handout, we have defined profit as a a numerical number, that is the difference between total revenue and total cost. And a firm tries to maximize that profit by trying to maximize the gap between total revenue and total cost. There are two ways we can identify profit maximization. Before we look at those two approaches, it is also important to understand what does profit maximization actually means. So using math, profit is maximized when increasing output does not change the level of profit at all, which means that you are going to maximize profit when selling more no longer maximizes your profit. So that's how we think about profit maximization. So the notation that I have just written is a mathematical interpretation of profit maximization, where we are differentiating the profit function with respect to Q. So if we apply the same rules of differentiation on the right-hand side of the profit function, we are going to differentiate total revenue with respect to Q, and then we are going to differentiate total cost with respect to Q. Based on our previous discussion, we know that the first term is our marginal revenue, and the second term is our marginal cost. If we substitute those expressions in the second line, we can therefore find a very interesting condition that profit maximization needs to satisfy. And that is the fact that the difference between marginal revenue and marginal cost has to be equal to 0. And when we reorganize that equation, we find a very familiar looking profit maximization condition where marginal revenue is equal to marginal cost. So therefore, we can think about two alternative approach of finding profit maximization. One, we can find an output level where marginal revenue is equal to marginal cost. We will sometimes call that the marginal approach. And sometimes, and then there is a secondary approach where we are going to, find the maximum gap, an output level where the gap between total revenue and total cost is maximum. Okay, so that's basically the two approach. Now, these two approach can be analyzed in a graphical setup, which is being done in your handout, and the handout uses numbers and a numerical table that you can use to derive the same results. Instead of following the handout, I am going to basically be drawing them separately so that we can give you an idea about what is at stake. Okay, so the first approach that I am going to look at is the total revenue, total cost approach of profit maximization. Okay, so I'm going to draw these graphs. Based on our knowledge about the total revenue and the total cost curve, we know that our total cost curve kinda looks like this. It basically falls initially and then rises very, very dramatically. And our total revenue curve initially increases and then sort of decreases. So there is a possibility that total cost and total revenue curve would intersect each other. I have drawn this in a sort of hypothetical way, so please do not worry about that. In my hypothetical graph, I can see that total revenue and total cost are intersecting at 2 points. Let's call the first point A and the second point B. So at these points, the total revenue and total cost are equal to each other. Please be aware at these points, your profit is actually 0, which is a big problem because we do not want 0 profit. we actually want maximum profit. Profit in this approach is going to be maximized where the gap between total revenue and total cost is maximum. So if you look at the graph, you would realize that the gap between total revenue and total cost is maximum somewhere around the output level of, let's say, Q star. So this Q star maximizes the gap between total revenue and total cost, and hence the gap, maximum gap, indicates maximum profit. Okay, so that's our total revenue, total cost approach. In the total revenue, total cost approach, we find the output level where the gap between the total revenue and total cost is maximum, and we are done. Before we move to the second approach, I would like to point out that at this particular output level, you're going to find yourself a situation where these two curves are going to be almost parallel to each other at this output level, which means that at this output level, the slope of the total cost curve, which, as you know, is equal to marginal cost, and the slope of the total revenue curve, which we learned is equal to marginal revenue, can also be equal. So this total revenue, total cost approach as a bonus also indicates that your profit is maximized where marginal revenue is equal to marginal cost. You don't need to remember the last part of the analysis that I just carried out. I just wanted to do that for a continuation purpose. So that's our total revenue, total cost approach. I'm going to add one more slide, and in that slide, I guess we can add more slide. Okay, and in that slide, let me just talk about the so-called marginal revenue, marginal cost approach. Okay, so first I'm going to draw them. We already have seen various shapes of cost and product revenue curves, and from my previous discussion I have highlighted that marginal revenue curve, when they are drawn within a space of P and Q, is going to be a horizontal line, and your marginal cost curve can be a U-shaped curve. Okay, now we are going to think about several points. Let's say A, B, and I'm going to look at a point like C and a point like D. Okay, I'm going to start with A, point D. At D, this is basically an output level. Let's call it Q1. At this output level, you can see that your marginal cost is greater than marginal revenue. What does it mean? So at output level Q1, your marginal cost, the extra cost associated with your production, is greater than the extra revenue that you get. So this is clearly not a profit maximizing situation, right? When you are at a situation like that, it tells the producers to produce more because costs are too high. You might ask yourself, why would the producer be producing more if the costs, the additional costs, are higher than the additional revenue? The answer is that our producers know that as a result of law of increasing returns, if they produce more in this region, your costs will start going down, and therefore the level of profit will start going up, right? So that situation can again come to a halt when we look at, let's say, a point like A. At point A, let's say the output level is Q2. At point A, marginal cost is equal to marginal revenue. It seems like this is a profit maximization point because it satisfies the the equilibrium condition that we saw in the previous slide. The problem with A is that our producers see the possibility of further decline in their cost, and they know that the more cost goes down, the higher the profit level goes up. So they are not going to stop at A because they are greedy. They want to produce more so that further level of profit can be increased. So our producers will continue to produce more, and then we will reach the point B where we get the same condition. Marginal cost is equal to marginal revenue. Let's call this output level Q3. Now this is an identical equilibrium condition with one very important difference. So our producers know that if they produce anything beyond Q3, the marginal cost curve is going to rise above the marginal revenue, and therefore their level of profit will start going down. So point B is where our producers will stop. They are not going to produce any more, and hence this will be the profit maximization point. Now, the final point that I'm going to look at is C. At C, we look at a very similar kind of problem like D, where marginal cost at C, let's call C an output level of, let's say, Q4. Marginal cost is again higher than marginal revenue. But please notice the difference between your D and your C. At D, producers were seeing that the marginal cost was going down, so they were producing more. At C, the producers are seeing marginal costs are going up. So it doesn't make sense for them to produce more. So what will happen is that if a firm accidentally ends up producing at the level C, the firm will cut back on their production. So these are the four possible scenarios that can happen when we are trying to find profit maximization using the so-called marginal revenue, marginal cost approach. And what stands out is that our profit maximization is going to be found at point B, where marginal cost and marginal revenue are equal to each other. Okay, so that is interesting. I guess we can now go back to our actual, class lecture note. And I basically have looked at several of these issues where I have shown you how marginal cost and marginal revenue being equal to each other derives the profit maximization condition. I basically have covered the the so-called total cost, total revenue approach, where we had these intersections between total revenue and total cost curve. Notice here, total revenue curve is much simpler, and the gap and the profit was maximized where the gap between these two curves were maximum. Let me highlight that in the graph. So in the graph, you can see clearly that the gap between total revenue and total cost is maximum when the output level is 10. And you can see that by using numerical calculations, this is also the output level where your total revenue is, where your profit is maximum 29. Then we have this marginal revenue, marginal cost graph. And again, the graph that I showed you was much more complicated. Here you have marginal cost curves intersecting only the marginal revenue curve once. But finally, the idea here is that your profit is maximized where marginal revenue is equal to marginal cost. And at any output level before that, we saw that firms will continue to produce more, so they will be moving towards the output level 10. At any output level beyond 10, they would like to cut back on their production, because at the output level 10, marginal revenue is equal to marginal cost, and that's how profit is being ensured. Okay, so this discussion that we just had talks about profit maximization. This is a theoretical condition that needs to be satisfied if the firm wants to maximize their profit. Our next discussion would be a more realistic or numerical approach of calculating the level of profit. How do we measure profit when a firm is trying to maximize profit? I know it sounds like a strange question, but let me walk you through this. So I'm going to again share my PowerPoint slides, and I'm going to do a little bit of calculation on the profit function. So profit, again, is written as total revenue minus total cost. Now, I know that average revenue is total revenue divided by Q. And in the previous slide, I told you that average revenue can be written as P. And also, I'm going to talk a little bit about average cost, because it is going to play an important role. Average cost is total cost divided by Q. So therefore, I can write total cost as average cost times Q, right? Okay. So with those, reinterpretation of average cost and average revenue, let us define our profit function one more time. So our total revenue and total cost, our total revenue can be written as P times Q, and my total cost can be written as AC times Q. I can take a Q common, and my profit function can be rewritten as Q times P minus AC. So when you look at this equation, you realize that this Q is always positive. So whether your profit is positive or negative actually depends on the terms inside the parenthesis. For example, if price is greater than average cost, that would mean P minus AC is greater than 0. Then it would mean that your profit is also positive. If P is smaller than average cost, that would mean that P minus AC is smaller than 0. And from the same equation, we are going to find that if P minus AC is smaller than 0, my profit is also smaller than 0. So these are two very important conditions. If profit is positive, that has to come from the fact that your price is greater than average cost. If your profit is negative, which means that you are earning a loss, that can happen when price is smaller than average total cost. So with those expressions, let us now go back to our notes again. Okay, so if you look at it, when I defined good times and bad times, good times is a time when a firm is earning profit. That usually happens when price is greater than average total cost. By the way, ATC and AC are the same. Sometimes we call it average total cost, and sometimes we just call it average cost. They are the same thing. So if you use the same notations, you see that if price is greater than average total cost, your profit is positive. And we have a graphical illustration here where you can see that if the profit maximization price level is found at a point where marginal cost is equal to marginal revenue, and that price level at that profit maximizing output 15 is higher than the average cost at that output level, your price is greater than your average cost. Your price is 10, your average cost is 6, so your profit per unit is actually P minus ATC, which is $4, and then your total profit is P minus ATC times Q. You see that it's 200. Now, you can also have a loss where you find a profit maximizing output level. You find a profit maximizing output level at let's say roughly about at output level 30, and at that 30 you go up to the average cost curve and find that the average cost at that output level is 5 and the price is 3. So you can see clearly that this is a situation where price is smaller than average cost, and if price is smaller than average cost, you are going to get a loss. Loss is going to be equal to the difference between average total cost and P, and you can see that the amount of loss is 60. Now, sometimes you can also, this loss is, you can also think of it as like a negative profit. So the basic idea here is that if price ends up below the average total cost, you earn loss. If price ends up higher than average cost, you earn profit. Okay, so the reason why we talk about profit and loss, good times and bad times, because both of them are a possibility for a firm in perfect competition. Before I continue further discussion about profit maximization, I would like to go back to our discussion of profit maximization, of our discussion about perfect competition. So I want to add one more, sort of point about perfect competition. So we had perfect competition as a market structure where there are large number of buyers, there are large number of sellers, firms, the goods that firms produce are homogeneous, and then we also will say that capital is fixed in the short run. Short run is basically a time frame during which our firm cannot make certain decisions about their production process. And that involves buying new capital because it is expensive. In the short run, however, firms can make other decisions like buy labor, buy raw materials and other resources. So there is a reason why we are going to fix the capital in the short run. There is a theoretical reason because it will help us to talk about something called shutdown. And it also is more realistic because when you look at a firm expanding their production process by, let's say, expanding their production plant, which is literally equivalent to buying more capital, that can only happen in the long run. Okay, so with that assumption, we are now going to go back to our notes. Okay, so we will now talk about shutdown decision in the short run. So what is shutdown? Shutdown is a situation where a firm decides that they are earning so much loss that it doesn't make sense for them to continue to produce, right? Now you might ask yourself, well, shouldn't any firm shut down at any level of loss? The answer is no. So I am going to therefore talk about two realistic possibilities in a production process. One is that it is possible to earn loss and still produce, and it is possible to earn loss and completely shut down. So we are going to look at both of these ideas from the perspective of economics. Let us think about a scenario where our firm believes that the economic loss that they are making is temporary. What does it mean? Sometimes there can be market fluctuations. Let's say like a seasonality where sometimes profit level goes down. So you can, okay, so this is creating some problem. Okay, so I guess seasonality. Seasonality is is an important feature. There are periods or quarters where firms do not make profit because market conditions are not in their favor, so they earn loss. So does it mean that after earning several quarters worth of loss, every firm should shut down? The answer is clearly no, right? If there is a expectation that in the future market conditions might change in the favor of the firm, a firm might decide to stick around to the business, still earning profit with the expectation that in the future they might make up for it. So that's why temporary loss presents a challenging situation for our firm, because they have to make the right choice. So the trade-off that our firm faces is basically a trade-off between a short-term loss versus long-term gain, right? If the short-term loss is small compared to the expected long-run gain, I would argue that a firm might produce even at a loss. Okay, so that is a very important point. There are several important points that I want to bring and talk about before I look at this so-called shutdown condition, right? The first thing that I want to do is I want to think about the cost of shutting down. So shutdown means a firm is not producing at all. Please remember that a shutdown condition or a shutdown situation does not necessarily mean that the firm is completely exiting the business, because they cannot exit the business in the short run. We assume that it's probably going to take a while for our firm to be able to liquidate all their assets, especially the fixed cost. So in the short run, it becomes very difficult to exit a certain industry. So shutdown, therefore, is thus simply not producing anything. So the cost of shutdown is that the firm will lose the revenue, obviously lower amount of revenue, but they're still going to lose all the revenue that they could have made by producing under a loss. So that's the first important part. There is a benefit, right? Because if you shut down, you basically save your cost, right? You save the total variable cost, which are the cost of hiring the variable inputs in your production process, like hiring workers, hiring raw materials. And if a firm does not produce, a firm do not need to buy those variable costs. So shutting down has a cost and benefit. The cost is the revenue loss. The benefit is the cost saving. Okay, now let us talk a little bit about sunk cost. Sunk cost is a very interesting concept. Sunk costs are costs that you have already committed or you have already spent on a production process. Most of the times, sunk costs are related to setup costs. Let's say you want to start a new business, you probably have to build an infrastructure, buy machines. Those expenditures are being carried out even before the production takes place. So that's why they are called sunk costs, because they are already sunk and your production decision is not going to be affected by this cost. So this setup cost has to be made anyway, right? Doesn't really matter whether you shut down, meaning that you cease to produce, whether you produce 1 unit, whether you produce 1 million unit. Those costs are costs that are sunk and you cannot recover them. Okay, so total fixed cost, the cost of that machine, that building, that electricity utility lines, they are all sunk cost. Now the importance about sunk cost is that when a firm is trying to make these remarkably important decisions about shutting down or continuing to produce at loss, sunk costs do not matter. Sunk costs do not matter. So we should therefore ignore the fixed cost and simply compare the revenue loss with the saving of the average variable with the saving of the variable cost to figure out whether a firm wants to produce or shut down. So the rule of thumb, the first rule of thumb is that you are going to shut down if the revenue that you are earning is so low that it cannot even pay for the variable cost. It cannot pay for the worker, it cannot pay for the raw materials, and that is a situation where it doesn't really make sense to excuse me, to continue to produce. So if this is the shutdown condition where total revenue is smaller than total variable cost, we can divide both sides by Q, and we find that the shutdown condition will be found where average revenue is smaller than average variable cost. Now, from our previous discussion that this average revenue is equal to price in perfect competition. So the shutdown condition is that if the price is smaller than average variable cost, our firm would shut down. Okay, so that basically filters into the formal shutdown condition, which is P equal to average variable cost. This basically is called the shutdown quantity. The quantity at which your price is equal to average variable cost is the shutdown quantity, and the price at which the average variable cost is equal to price is called the shutdown price. So you can look at it in many ways. One is that if the market price is currently the shutdown price, it means that our firm will cease to produce. If the firm, on the other hand, is producing the shutdown quantity, it will also cease to produce if the market price is indeed equal to the average variable cost. So there are alternative ways of looking at that. Okay, so the next topic, this task is to look at this issue from a graphical perspective. Okay, so I'm going to expand that graph a little bit. And notice that in this graph, in addition to bringing the marginal cost, average cost, we also have brought the average variable cost. So our profit maximization is found at the intersection between marginal cost and marginal revenue. So our so-called profit maximization point output is 7, but this output is not generating profit, as you can see, because at that output level, your average cost is $14 and your price is $3. So your average cost is way more than your price. Not only that, this price is actually equal to the average variable cost. How do we know this? We also know that this is basically the point where the average variable cost is minimum, right? How do we know this? Because we know from our previous discussion that marginal cost curve intersects the average variable cost at the minimum point. So if the market price is minimum average variable cost, this is going to be our shutdown point, our shutdown output level. Okay. If for some reason the price is, let's say, $10, I would argue that at that $10, the firm is still going to be making loss because average cost is 14, but the price that the firm gets at least covers the average variable cost of production, which means that the firm, if the firm produces at a price level of 10, which probably translates into an output level of, let's say, 9 unit, the firm can cover its variable cost, and it might also cover a little bit of fixed cost that are not important. So if the firm at price 10 is able to cover all of variable cost, it makes sense for our firm to produce at a loss. But if the price is $3 or any price below that, a firm will shut down. Okay, so that takes us to the last part of the discussion, and the last part of the discussion is again going to follow our graph. So when we look at the marginal cost curve, it seems like the point of the marginal cost curve where it intersects the average variable cost is the lowest level of output that our firm will produce. So 7 is the minimum amount of output our firm will produce. Our firm will not produce 5 units because at that 5, your market price, excuse me, at that output level, notice that your marginal cost is, lower than marginal revenue, so the equilibrium condition is not really being met. So none of these outputs are relevant in a sense that they are not part of the production decisions. The first or the lowest level of output that are part of the production decision is probably where the price is 3 and the output is 7. At any price higher than 3, our firm will make some kind of production decision, which means that they will produce something. In a range, they are not going to be able to earn any profit. In another range, they are going to be able to earn profit, real profit. But combining those, we notice that the lowest point of the firm's production decision is at 7 units of output and $3 price. If we look at this particular part of the marginal cost curve that starts from the minimum point of the average variable cost curve, we notice that this part of the marginal cost curve shows combinations of price and the output our firm is producing. Our firm is producing at different prices. We see the marginal cost curve over and above the average variable cost curve shows different level of output our firm produces. Therefore, this upward sloping part of the marginal cost curve above the average variable cost curve is the supply curve for our firm. Okay. So that concludes my discussion about the profit and how we can find profit maximization condition, how we can find profit maximizing output level, and then we talked about the possibility of a firm producing in the short run at a loss, which is a unique situation. We also looked at the so-called shutdown condition, where the price is so low that it cannot cover even the variable cost of production, and our firm exits, our firm ceases to produce. It shuts down. The shutdown condition is actually quite important because at shutdown, that shutdown point helps us to basically define the supply curve for our firm. Before I let you go, I would like to highlight one other point. That particular point arises where the market price is about $14. So at $14, notice something that is very, very interesting, right? At $14, your price is equal to marginal cost, is equal to marginal revenue, and it is also equal to average cost of production, right? Average cost of production. So what this means is that at that output level, your profit is Q times P minus AC, and the term inside is actually are equal to each other, which means that at that output price level 14, your profit is actually 0. And that kind of profit where a firm earns 0 profit is called a break-even price. So break-even price is 14, where a firm earns 0 economic profit. 3 is the shutdown price, where our firm shuts down, does not produce anything. Any price between the break-even price and the shutdown price is a price at which our firm earns loss. And at any price over and above the break-even price, our firm earns profit. Okay, thank you very much. If you have any question, please send me an email. Have a nice day.